Alright, so I hope I'm recording. Let's try and do 24, 25, and 26. These are our combination functions. Now let's see. I've had to restart the computer, so I need to open up our notes to show you. It's on a previous video, but in case you didn't watch that video, let's see. I need to go to, well, I don't think I have it in our folder, but I have it in this folder of our notes. Alright, or at least I think, uh-oh, what was that? It's going to open. This is a disaster. Alright, so let's try it again. Open that guy. Open with. There we go. Alright, so let's scroll down somewhere down here. How close did I come? Sorry about this. I meant to have this already cut and paste. There it is. But I have to keep restarting the computer because this keeps freezing up. It's definitely not cooperating. Alright. So let's take, I have one transformation, two transformations, 3, 4. I've got 5 transformations here. The most we can have is 6. The transformation that we're lacking is a negative on the interior that would reflect it across the y-axis. So there's a lot of transformations going on here. If you just do it randomly, the order, it's very unlikely that you would end up with the correct answer. We need to know this order of transformations in order to get this correct. Alright, so we need a starting point to be able to transform. We need a point, the coordinates of a point on the graph of f, and then step by step we'll have a sequence of transformations that'll eventually lead us to a point that we know to be on the graph of g. So this f evaluated at 1 equals 3 is telling us that the graph of f is passing through the point 1, 3. Alright, now our first transformation according to our order of transformations is horizontal shifts, adding and subtracting to the x variable. And remember, on these first two, these transformations that are horizontal, remember when you're plotting points, x is left and right, and that's horizontal, and y is up and down when you're plotting points, and that's vertical. So that's why you see horizontal in the first 2 steps and then vertical in the last 2 steps there, because we're starting with changing the transformations on the x coordinate, left and right, horizontal. Then we go on to apply our transformations to the y coordinate, which is vertical, up and down. So the first thing that we do is shifts left or right, if there is any shifts to the left or the right. Well, hey, this time there's the -1. It's bizarre in its behavior. You actually add 1. This is actually going to shift the graph to the right 1. So to the right of 1, 3, 1 unit to the right is 2, 3. So now I've taken care of that, and I'm working with this new point. And the 1/2 there, well, even though it says to multiply x by 1/2, we're actually going to take the reciprocal. We're doing the opposite of what it says to do. Instead of dividing by 2, we're going to multiply by 2. So that description is a horizontal stretch. And that's by a factor of 2. Now, you don't have to write these descriptions. I'm just doing this to try to help you to possibly understand this better. So this is telling me to multiply the x coordinate by 2. 2 times 2 is 4. So now I'm through with the transformations on the x coordinate. 4 is going to be in my final answer. Now, to figure out what the final y coordinate is going to be, we need to apply these transformations. Now, technically, this -3 is actually 2 transformations. It's a vertical stretch by a factor of 3, and it's also a reflection across the x-axis. But since both of these are affecting the y coordinate, and it's behaving normal, you know, if I change the sign and then multiply by 3, or if I multiply by 3 and then change the sign, either way, I'm going to get negative 9, because 3 times 3 is 9, and the opposite of 9 is negative 9, or positive 3 times the negative 3 is negative 9. So I've taken care of two transformations there, a vertical stretch and a reflection across the x-axis. Like I say, we don't have to continue writing that. This reflection across the x-axis and then the vertical stretch by a factor of 3 is just maybe helping you with some of the previous problems. So maybe it's a good idea that I write that. Okay. It's kind of sloppy there. Sorry about that. So now we're working with this 4, negative 9. And the last thing we're going to do is the vertical shifts. If we're adding to the output of the function or subtracting from the output of the function, we're shifting it up, lifting it up, or pushing it down, shifting it up or down. And it behaves in a normal way. Plus 3 is up 3, and 3 units above negative 9 is a negative 6, because negative 9 plus 3 is negative 6. There's my final answer. So here we go. Its final answer is choice C, like Charlie. Let's take a look at the next one here. Let's bring along our notes here. All right, so the first thing that I notice is that x term is not first. It says 6 minus x. But in my notes, it has the x first. So I would suggest that you rewrite it, that you think of this as a standard form. I would suggest that you look at this g of x, and the 1/2, that's fine there. But write it as negative x plus 6. So that way, maybe you won't make a silly type of error. At least it helps me. So if it helps me, I'm hoping that it'll help you. So do I have a horizontal shift? Yes, because I'm adding to the x-coordinate. So I'm starting here at this point with negative 4, comma 2 is on the graph of f, and through a series of transformations, we're going to come up with a point that we can guarantee is on the graph of g. So we shift this horizontally. The plus 6 is actually to the left. We're actually going to subtract 6. Negative 4 minus 6 is a negative 10. Oops. I left the y-coordinate alone because all I did was deal with this plus 6, which was actually subtracting 6. Now the negative sign. We actually do change the sign. But maybe it's bizarre in its description that changing the sign of the x-coordinate is a reflection across the y-axis. Because this was to the left of the origin, left 10, and now it's to the right 10. So changing left to right is reflecting across that vertical line, that vertical axis, the y-axis. All right, so now we have 10, 2. And we're through with our transformations on the x-coordinate. 10 is going to be my x-coordinate now in my final answer. Now I start affecting the y-coordinate. I've only got one transformation. And the y-coordinates, everything is normal. If it says to multiply it by 1/2, we multiply it by 1/2. So half of 2, hey, that's 1. And our final answer is 10, 1. And there it is, choice B. All right, so let's take a look at the next one. Let's bring along our order here. All right, so I've got 1, 2, 3, 4 transformations. I'm starting with a point 310. The plus 2 is a shift actually to the left, so instead of adding 2, I subtract 2. And so 310 is transformed into 110. 1 comma 10. Well, now that we reflect it across the y-axis, we change the sign of x. The opposite of x, well, the opposite of 1 is negative 1. So now negative 1 is going to be in my final answer, and I begin to do the transformations on the y-coordinate, on 10. First, I'll change the sign. That's a reflection across the x-axis. What was up is now down. And now the -1, you shift it down 1 unit, and it's -1 comma -11, and hey, that's choice D. So I hope those help, and I'll talk to you later. Bye.